Yeah.
We're studying IGCSE mathematics and we're starting probability 3. Now today we're learning all about probability. In the book we're starting further probability, right? This is the chapter, if you can see the book. Chapter 34, further probability, the last chapter in
I
our...
cannot see the book.
Now can you?
Yep.
Okay.
Yeah.
Now in this chapter we're studying all about further probability. Just a second. Fine. There's just a few things. It's pretty easy. Most of the difficult parts were removed in 2019, so you don't have to worry. Okay. So the first thing you need to care about is combined evens. Okay. Combined evens. What else? Conditional evens. And in combined evens, we have two things. In combined evens,
Is
we
this
have...
related to the tree diagram?
Yes, combined events are tree diagrams and square diagrams. Square diagrams.
Okay.
Have you done square diagrams in
Okay.
class?
No, we only started tree diagrams today.
All right. Okay, no problem. Conditional evens. I will do all of this today. We'll finish everything today. Conditional evens are... yeah, there's nothing in there. It's just tables. Yep. Reading data. Mostly, yep, that's it. Fine. Let's start with combined evens. The first thing in combined evens is the tree diagram. Fine. But before we even do the tree diagram, let's do the square diagram because you have done that already in class. Let's do this first up. So first off, let's see. Let's take an example of, let's say, a question, perhaps, of, let's say, you're tossing two coins. Right? You're tossing two coins, and I need you to write all possible events that can occur.
Okay, so it can be both tails, both heads, one head,
Right.
one tail, one
But
tail,
instead of
one
writing,
head.
let's say that's the correct answer. Instead of writing, let's just show all the possible outcomes. What we'll do is we'll look at we'll make something like this: tails, heads, heads. Well, it's like a Punnett square. You have T.
Okay, that's what I was going to say. Inheritance.
Now, sorry, you have a tail, head. Okay. Now this is your first coin. It can either give a tail or a head.
Yeah.
And you have your second coin.
Yeah. Yes.
The possibilities you have are TT, tail, head, head. Now both of them are codominant. Okay, yep. What's happening is you have these events happening. Now if I ask you, what is the probability, the P of TT? Anas, tell me.
1/4.
1/4. What is the probability of TH?
2/4.
2/4. Pretty easy. And finally, HH.
1/4.
1/4. Now you can simplify. In probability, there is no need to simplify. It's your choice, right? But it's a good practice to simplify all your answers. That's a good practice in the exam. Therefore, I want you to simplify your answers if it's possible. Done.
Yeah.
Okay. Now this is yeah. Ask, tell me.
We'll also put in the percentage.
The percentage, no, not the percentage. Only in the fraction form. You're not multiplying with this 100. Okay, this with 100. Unless they ask in percentage. Even if you check your book, we do not have any percentage answers. Okay, it's always fractions. There's no percentage in probability. Is that clear? All of you?
Yeah.
Shreya, can you hear me?
I can.
Now you have to work with me on the next question, Shreya. Let's say the question is, okay, let's say, just a second. Question 2. A six-sided fair dice is rolled, and consecutively a coin is tossed. Okay, now that's what's happening. Your job is to show all the possible evens.
Okay.
Yep.
So first would be like the coin being tossed, head, and then the dice 1, 2, 3, 4, 5, 6, like head 1, head 2, head 3, head
Will
4,
I say
head
head?
5.
Yeah. So will I do this? That's pretty long, right? At 6, then I can have tail 1,
Tail
tail
1, yeah.
2. That's not the best way to do this. That takes a lot of space. What the better way of
Yeah.
solving this is make a square diagram like this. Write tail head, and over here write 1, 2, 3, 4.
So this is called combined evens, right?
Combine evens, yes. Now so you can get a 1 tail, a 1 head, 2 tail, 3 tail, 4 tail. Now you're still writing this, but it's your choice. You don't have to write it. There's no point. No one's asking you to write it, because if you see over here, you can understand that it's 1 tail 1, right? Okay. Now your job now is to see what is the probability of score being more than 10. Now one thing I forgot to mention in the question, if you get ahead, then score is multiplied by 2. And what is the score?
Can I see the diagram once, like the top
Yeah.
diagram?
Yep, you can. A 6. Okay. Anas, read the question.
A 6-sided pair dice is rolled and consecutively a coin is tossed. If you get a head, then score is
Just a second. Is the score? Shall I read the question again? Come on, ASAP.
Yep. So 1 second. Let me zoom in. Okay, a six-sided pair dice is rolled consecutively, and a coin is tossed. The face the dice rolls on is the score. If you get a head, then the score is multiplied by 2.
Right. Okay. So now you have this diagram. The question is, what is the probability of score being more than 10? Okay. So let's do one thing. We're going to write the scores here. Instead of writing T1, let's write the scores. So when it's 1 and tail, then the score will be 1. When it's 1 and head, the score will be 2. 1 times 2. Yes?
Yeah.
So whenever you get the heads, the score, the coin, the dice doubles. That's your score. So now we're writing all these scores. So it is going to be 2. Now Anas, when you get a 2 and a tail, what is the score?
Okay.
It will be 2. Because when you get a tail, that's just multiplied with 1. So 2. 3, 4, 5, 6 in the same way. Head, it will be 4. 6, 8, 10, 12. Any doubts here?
Yeah. I didn't understand the concept itself.
Okay, so let's see. This is your coin. This is your dice. The game we're playing is, I'm going to roll a dice, okay? And whatever the side of the dice it lands on, that is the score. But then you also toss a coin, and if the coin is heads, then the score doubles. Otherwise, the score stays the same. Yeah.
That much I understood, but then I didn't understand how you did the square thing.
Yeah. Okay. Now what we're doing is, we don't. It's a rough sketch thing, right? They don't ask you to. They usually don't ask you to make this in the exam, right? But this is a way to use. It's a method to solve a question in the exam, and they will look at this. You may get method marks. This is your score. So what we're doing is, these are the evens or the scores. Okay.
Yeah.
So even slash the scores. What are the evens? The scores. So instead of writing 1 T and 1 head, we're directly writing the score. So if it's 1 and head, that means the score is going to be 2. Make sense?
Yep.
And if the dice is 2 and its head, then 2 times 2, that's 4. Does that make sense, Anas? Anas, does this make sense to you? He's not here. Okay, Shreya, any doubts? I want you to find the probability of score being more than 10. Quick. What is the probability of the score being more than 10?
Okay. Can I answer?
Answer.
So it's 1 by 12.
1 by 12. Yep, that's the answer. So 1 over 12. You have 12 evens, 1 over 12. This, you can circle this if you want. Fine. Now, what is
Yeah.
the probability of the score being an even number?
An even number. 1 second.
Shreya, I want the answer from you.
Okay, Shrey isn't here.
Alright, then Manvi, answer.
So it's 9 by 12, which is 3 by 4.
So now, see, the thing is, in the exam, we want to be very organized. So one way is, let's say for the first part, we made a square, right? Over here.
Yeah.
Now in the second part, let's make a circle. So let's circle all the even numbers. This is it. This is it. This is it. This is a square even. This is even. This is even. This is
Yeah.
even. This is even. This is also even. Now we'll just count the number of the circles. Okay. This also
Can you
helps.
show the question once?
Read the question. Probability of score being even.
No, like the whole the first, like the description thing. Yup. 1 second. I'm just writing it down so I don't forget the concept.
All right. All right. Right.
So for the tree diagram, you're supposed to multiply all the probabilities, right?
Yes, you're supposed to multiply all the probabilities, but in this over here, you're just supposed to count and take them. This is also combined even, yeah, but this is not being multiplied. Is that clear? Now we'll have to multiply
Yeah.
it. Let's see how that works. So first things first. Let's look at the first part. The probability of the score being more than 10. Okay. So when is it more than 10? It's at 12. Yes.
Yeah.
Okay. So at 12, what we're getting is we're getting a dice at 6. Okay. So that
Yeah.
means, can I say 1 over 6?
Yeah.
And the probability of getting a head is 1 over 5. Yes.
Yes.
Not really. No, that's not 1 over 5. It's 1 over 2.
2. Oh, wait. How?
Half. Coin. 2 evens. The probability
Yeah.
of getting a head. So let's write this down in the format of combined evens. So P greater than score greater than 10. Score greater than 10 is going to be the dice 6. So P dice equals 6 into P coin is head. Is that clear? Now, when are you getting something more than a 10? You're getting it here. When the dice is 6 and when the coin is head. Is that clear? Okay. Now, if I multiply the probabilities together, what is the probability of getting 6 on a dice? It is 1 over 6. And what is the probability of getting a head?
1 over 6.
No, you have two sides of a coin. Let's look at the coin.
Okay.
Two sides of coin. 1 over 2. Half. Therefore, the answer will be 1 over 12. Yes?
Yup.
And what was your answer which you got from here? There are total 12 evens. So the answer was also 1 over 12. Okay?
Yup.
So you can solve it both ways. But this method directly gives you the answer. All you have to do is count the
And
evens.
it's easier. Yup.
So it's a more organized way. It's actually pretty
Yup.
obvious for you to know this because that's part of the syllabus. Now, let's look at the probability of score being even. Fine. So when does this happen? The score is even when the dice is 2. So let's say it's either 2 tail, 2 head, or it's 1 head, or you can also have a 3 head, or a 4 tail, 4 head, and 6, just saying 5 head, and 6 tail, 6 head. This is what you're getting. Now in real life, if you had to use the other multiplication method, would it not take you a lot of time? You would have to do this. You would have to do 1 over
You just have to count this right now. Like
plus 1 over 6 into 1 over 2, plus 1 over 6 into 1 over 2, plus 1 over 6 into 1 over 2. And you would keep doing this. How many times? Count how many events do you have?
A lot.
1,
Okay.
2. How many events are there?
There's 6, 7, 9 events.
9 events. Are you sure about that? Yes, 9 events. So if the events are 9, can I say, since each of the probabilities are same, I can multiply all of this with 9. Okay, and let's see what the answer will be. The answer will be the same whatever you get here. The total events are 12. So at the end, the answer will be 9 over 12. Right? What is 6 into 2? 12, Manvi. So we will get 9 over 12. That's it.
Okay, wait, my mic is mute. Okay.
So 6 into 2, the denominator will always be 12, right? All of these add up, 1 over 6 into 1 over 2, because all of these, the score being 1, score being 2, 3, 4, all of them have the same probability. And head or tail have the same probability. So you don't, it's pretty easy that you just use the square diagram. Both the ways give you the same answer. There's just the proof. There's the proof of concept. Done. Fine. Let's look at another question just like this. The thing is, it's pretty difficult for me to teach everyone if they're not in class. So where's Anas? Can you ask Anas? No, you don't have Anas's contact.
Exactly.
I see. Exactly. I remember. See, I remember most of my students. I do remember.
Yep.
Some students I forget, and I have to ask their names. But others, the one who are attentive in class, I do remember them. Good. Yep. Rejoin. Fine. Because I'm pretty bad with names, usually.
Yeah.
Question number 3. Let's say now what's happening is you have a spinner, you have a 7-sided spinner is rolled, a 7-sided spinner is spun, and let's say right away what happens? Let's say a 5-sided dice is rolled. The score, or let's just make it more realistic. You won't get a question like this in exam. Sometimes questions are difficult, but not usually. So let's take two 6-sided dice are rolled. 2 6-sided dice are rolled. The score is sum of both, and let's say the score of Andrew. The score of Andrew is sum of both, and the score of, let's say, Tate is product of both. Is that clear?
Yeah.
All right. Okay. So now how do we solve this? Do it on your notebook. Send me the answer. The probability of you're supposed to find is P of score of Tate is greater than score of Andrew.
Yeah. So Andrew could probably get, okay, 1 second. 2 6-sided dice are rolled. So you want the probability of like both the dice together?
Yes, that's the thing. Now 2 6-sided dice are rolled. Let's solve this together actually.
So it'll be 1 2 3 4 5 6, 1 2 3 4 5 6 on both the sides, right?
Both the sides, yes. Let's do it on the board. Now, do you have the software installed on your PC right now?
Yeah, but I'm not joined. I didn't join with it.
Now, I want you to join from the PC. And I want you to see
Wait,
now
I-
we're getting more
I am on
disciplined.
the PC. I am on the PC, but I'm not. I'm not joining through the app.
Download the app because now there's more discipline happening. Where we're going to now, from now onwards, the whole level of my classes are going to change. We're going to finish a lot more syllabus
Yeah.
now, and a lot more discipline is required. So download it, and I will ask you to do
Yeah,
questions on
it
the
is
board.
downloaded, but it's not working for some reason.
I see. I see. Okay. Okay. So 1, 2,
What is the
3,
meeting
4.
ID?
The meeting ID is. I can share it with you. Just a second.
Yeah.
I'm back.
You're back. Welcome back, Anas. Now you missed quite a bit. What happened?
The internet went out.
The internet went out. Now I don't see this. This never happens with YouTube, does it? We have continuous Netflix, we continuous YouTube, but when it comes to class, things do happen. That's okay. But you have to rejoin ASAP. Now we're
No,
unless we're trying to
let's
solve
see.
this question. Okay.
We didn't-
Read the question, Anas.
Okay, I'm trying to join. 1 second.
Anas, read the question 3.
Alright. Six-sided die. Two six-sided dice are rolled. The score of Andrew is the sum of both. The score of Tate.
Okay, it's showing the meeting password is incorrect. Can you tell me what is the meeting password?
Alright.
It's 0. Everything is 0. Check the meeting
Yeah,
password.
It's like 10 zeros.
yeah, I'm trying hard, but it isn't working.
You can also join with the link. Okay.
Yeah, it's not. It's still
Yeah,
showing
okay.
the meeting.
Fine. Now look at the board, all of you. You have probabilities. Fix it after class. Try joining after class. Stay with me for
Yeah,
5 seconds.
sure.
5 minutes. Now P score of Tate is greater than score of Andrew. That's what we're trying to find. Now let's say this is Andrew, or let's say this is the first dice. First dice,
Yeah.
second dice. Now 1, 2, 3, 4, 5, 6. That's what we have right now. Okay. Just a second. Let me finish eating. Okay. Now can you hear me?
Yep.
Okay. Now let's see. Let's try to find the score of Andrew and Tate. What is the score of Andrew? Anas? It is the sum of the both, right? So let's say this is the sum of the both. So 2. This will be 4. 4, 5. Sorry, no. 2, 3, 4, 5, 6, 7. That's Andrew's score in the first row. Yes. What I'm doing
Yeah.
is I'm adding them together. Now let's find Tate's the score of Tate. If I try to do that, this is how it will look. Multiply them together. So 1, 2, 3, 4.
Why are you multiplying them?
Because that's the score of Tate, the product.
Okay.
And then we'll have 5, and over here we'll have 6. You can put a comma in between them to make it simpler. Okay.
Yep.
Now do the rest for all of these. So we'll have tell me the answers. I'll write it down.
I have a question. So my internet
Awesome.
went out again. I missed this part. So can you explain it again?
Yes, I'm explaining again. You have 2 dices are rolled, right? Make a table like this, 2-sided table,
Alright.
a square diagram. Okay. You can make a square like this, a square. I'm not finishing the square. Usually you have a square, but it's not right. Now the next thing you have to do is, first up, you have to find the score of Andrew. Let's do that. Let's forget the score of Tate for a second. Let's find the score of Andrew. Now what is 1 plus 1? That's 2. 3. Let's use the red color. 1 plus 1 is 2. This is 3. Then we'll have 4, 5, 6, 7. Then we'll have 3, 4, 5, 6, 7. Yeah? 4, 5, 6, 7, 8. 5, 6, 7, 8, 9. 6, 7, 8, 9, 10. 7, 8, 9, 10, 11. 8, 9, 10, 11, 12. Is that clear? You're just adding them together. Nothing complicated,
Yeah.
yes?
Yeah.
Now let's put a comma and let's find the score of Tate. Now you have to multiply them together. 1 into 1 is 1.
Oh, okay,
2,
okay, I get it.
4, 5, 6. Do the rest. Now your
Alright.
job, do it on your notebook as well. Okay, Manvi and Anas, do them on your notebook.
Yeah.
Send me a picture.
Yeah, I'm doing it.
We have finished everything in maths, haven't we? Almost everything,
No.
right?
Yeah.
What is left?
We
Not
didn't
everything.
do finance. We didn't
Yeah,
do
the
in
first
finance.
chapter is right. Chapter 1 to 10, we haven't done that. We didn't touch all of
Yep.
that. But we started from chapter 11. We finished everything till functions. We did straight line graphs.
Yeah.
We did symmetry, angle properties. We did mensuration as well. We did trigonometry. No, we haven't.
Yeah.
But I have done it
we
with
did basic trigonometry,
basic
but we
trigonometry.
didn't do further.
Further.
And we didn't do vectors.
Vectors, yeah, vectors. I see. Transformations. That's left. Okay.
Yeah.
Now, as soon as you're done, send me the picture ASAP. Quick, come on.
Yep. Sending it.
My graph is like, I mean, the table is like a bit weird.
Weird. That's a very good way to describe maths. Maths is weird, but you
No,
have to
the
do
one
it.
I made. The
The
one
one
I
you
made.
made. Show it to me. I'll fix it.
Right. I'm not done yet.
You're not?
No, I'm almost done. I'm on the last
Oh yeah.
one.
Okay. Fine.
I'm doing it too.
Yeah.
I'm
So
doing
both of you.
tail right.
Same the picture. Send the picture. I want both these scores, Andrew and Tate, not just one.
Yeah, I'm doing both of them. I'm done with Andrew and with Dave. I don't have the ruler right now, so my lines are a bit asymmetrical.
Alright, wait, let me send you the picture.
Okay, I'm
I
sending
can't
it.
send a picture because my mom won't give me the phone.
All right, guys, can you hear me? Now I
Yeah.
need the picture
Yeah.
from you. Have you sent it?
I sent it just now.
I can't send it.
You can't send it.
Yeah, my mom isn't giving me the phone.
The phone. Okay. Now one thing, you're making two tables. That's the problem. Manvi, there is a problem here.
Yeah.
The problem is you're not supposed to make the two tables. You're supposed to write the answer first thing first. You're supposed to write the answer directly. So 2, 3.
Okay.
This would be
I
4
realized that later. Yeah.
later. And another thing, you're not supposed to make two tables ever. The whole point of getting a square diagram is to have everything in one table. Okay. So how do we solve that issue? You have to put a comma here, and then put the score
Yeah.
of the other person like this.
Yeah.
Commas. Because that will only help you, because otherwise this is useless, right? Why? Because you can't really compare things. So let's do it here. This is what your table will look like.
Yeah.
2, 3, 4, 5, 6, 4. That's what you have. Put the commas in there. You don't have to. It's your choice. Okay. Now you have these numbers here. The red score is for Andrew. The purple score is for Tate. Now your job, the probability you're trying to find is when are these scores greater for Andrew than for Tate? That's the answer. That's the question. When is the score greater for Tate than of Andrew? Let's circle those areas. If I circle those places, let's see. Now first tell me which are the pairs. So red over here is Andrew, just to be clear.
Yeah.
Now where is the red number greater than the purple number?
Okay, so at 1 and 2. Okay.
Okay, let's mark this down.
The first row. The whole first row.
Okay. That then
I think all of wait, no. Yeah.
The second row, first one.
okay. All of these. Then what else? Let's see.
That's it.
That is it. Anywhere else?
No.
No. It's pretty easy. Now what are the total events in this? The way to find the total events is how many things you have on the top. How many numbers you have on the top? 6.
Okay.
You have 6 possible outcomes. When you had head and tail, you had 2 possible outcomes. Okay.
Yeah.
So if it's 6 and this is also 6, right? So you have 6 evens here. 6 evens and 6 evens.
Yeah.
So the total events will be 6 into 6. Or just count these if you want. You can count these. You have 6 rows and 6 columns. 6 into 6, 36. The total events are 36. And how many favorable events do we have? Where score of Tate. Oh, actually, we did it the opposite way. No, that's wrong. We were supposed to find the score of. Okay, just a second. Let's switch the question. Is that clear? Now, Manvi, read the question.
Okay, I cannot see it.
Can you see the question right here?
Score of Andrew greater than score of Tate.
Yes.
We did the right thing, right?
Yeah, we did it. I switched the question just now. Okay. So therefore, the answer of this would be, how many are there? You have 6 over here and 5 over here. Yes. How many events are there which form this argument, right? Which events, let's say, conform to this probability? How many events are there? The circle ones. How many blue circles are there? Count them. 11
by 36.
So 11 by 36. Any doubts?
No.
That's your answer? Done. Now the thing is, without doing this, would it be possible to solve a question like this? It would be pretty long.
Wait. 11 by 36.
11 by 30. That's what I was trying to ask you. Now, how many times, Anas, does Andrew have scored more than Tate? In all the blue circle areas, right?
times, yeah.
11 times. And how many total events are there?
So you just multiply it.
6 with 6, 36. Count all of these. So you have 11 which are Andrews more than Tate, but total is 1, 2, 3. All of these, there are 36 total events.
Yeah.
Right? So 11 over 36. Done. Now let's look at tree diagrams now. I hope this is clear for you. You're looking at tree diagrams.
Yeah.
Now, okay. We can do tree diagrams. Sure. Okay. Let's do tree diagrams. Fine. I won't do a lot of questions on this because it's actually pretty easy. I'm just going to tell you that, let's say, 3 coins are rolled. 3 coins are tossed. Find probability of, let's say, all heads. All heads. That's the first part of the question. Second part of the question is find probability of no heads. Okay. Third part of the question is at least 2 heads. Let's say 2 tails. Now these are the 3 kinds of questions you can get in the exam. This is the only kind of question you'll get in the exam, hopefully. Not hopefully, surely. Is that clear? Now if you can solve these all 3 kinds of questions, you can score full marks in tree diagrams. First off, Anas, read the question.
3 coins are tossed. 1, find probability of all heads. 2,
Okay,
find
stop. Let's make the first step always is to make the tree diagram. In questions like these. Now, Manvi, why are we doing tree diagram and not the square diagram in this case? Any guesses?
Because they asked for it.
No, they never ask for this. They will ask for tree diagrams, yeah. But if they don't ask, it's your choice, whatever you want. But the issue is, how many coins are tossed here? 3, right? Which is greater than 2. A square diagram only allows two possible combined events. A square diagram only works with 2 combined events, not 3. Is that clear? Right now we have 3 events here. We have 3 coins back to back. Okay. So what we can have is, let's start here. Now when I start here, I can get 2 things. I can get a tail or a head. Okay. After tail, I can get again a tail or a head. Again, I can get a tail or a head. Yes. Tail, head. Now you have to tell me how many possible total outcomes are there. The total outcomes.